Alright, so this was one of the problems that we wanted to look at yesterday, and I told you I would be showing you the videos today. Now, this is from adding and subtracting. So remember that in order to add and subtract, you have to have like radicals, which means you have to have the same index, which these guys do, but they're also supposed to have the same radicand. These guys don't. Now, when I'm trying to break these guys down like I did yesterday, I want to start with the smallest number, because a lot of times that will lead us to clues that'll help us figure out how we factor the other guy. So I'm going to start with 24. I'm looking for a perfect cube that goes into 24, not a perfect square. Make sure you pay attention to what you're doing. How would you break down 24? I would use 8 times 3. Why did you use 8 times 3? 8 is my perfect cube, right? And what does 8 give me? The cube root of 8 gives me the 2, right? Isn't the cube root of 8 2? Or am I tripping?
Yeah.
So then what does this guy become?
2 times -7.
Okay, so I have to multiply times this coefficient that's out front, so that gives me -14. And I have the 3 left inside the radical, right? We have to remember to keep that index. Now, this first radical gives me a 3 left inside. I wonder if the same thing would happen here for the other guy. Could I break this down as 3 times something? 1,000, or since we have the negative, because we don't want to forget about that guy. It's -1,000. Is -1,000 a cube?
I think it is.
You think it is?
I'm not quite sure.
Thinking isn't knowing.
10.
It is 10, but we have to make sure you see the negative here, so it's going to give you -10. So it's okay to have negatives inside cube roots? Is that true? We just can't have negatives where? Inside of square roots or even roots. All right.
So it's -30.
So this gives me -30. 3. I think you mean to say the
Cubic.
cube root of 3. So we have -30 cube roots of 3. Maybe you go back and you watch these videos and just play that over and over again. -30 cube roots of 3. Perfect. All right. So what happens when I combine these guys?
-1. Cube root of 3.
Not to the. It's -44 cube roots of 3. Like if this had not been cube root of 3, but it had been x, would you say -44 to the x? No.
That's the one that moves the exponent.
Right. And as far as we've seen so far, we have not had variables as the exponent, just as the base. But in college algebra, you'll see examples where the exponent is the variable. It's going to be super awesome. Any questions about this problem?
So when you find the perfect, in this problem, you find the perfect cube,
Perfect cubes, yeah.
Perfect cube, you're going to multiply it times the number on the outside.
Times that coefficient, yeah.
Times coefficient. And then whatever's left.
Right, and the remaining stuff, the stuff that's not a perfect cube that stays inside, just keep it inside the radical. Yes, Connie?
The negative with the negatives.
Right here?
How come the negative goes with 10?
And not, okay, so the question is, why is the negative here and not on the 3, right? You could have had it on the 3, but that would mean you would have a -3 left inside here, but you wouldn't be totally simplified because the -1 factor would be able to come out as a negative. Okay, so you would have to remember this, that if you had the cube root of -3, that is the cube root of -1 times the cube root of 3 And this guy is equal to -1, so you'd have -1 cube roots of 3. So I went ahead and connected it to the 1000, and the cube root of that was -10. Any other questions?